in this lecture, we will start about the crystal and its defect. No crystal is perfect other than the temperature 0 Kelvin. At 0 Kelvin, crystals are perfect according to the third law of thermodynamics. Means at 0 Kelvin, only the crystal lattice points are present at the corner of the crystal lattice. If the temperature is more than 0 Kelvin, then there must be crystal defect. The cations and anions dislocates from their position and a vacancy creates. Hence, this dislocation of ions are called crystal lattice defect. Now, crystal lattice defect causes either if it comes out of the system, means lattice point comes out of the system, then density of that crystal decreases. From the natural density, this density decreases. If this is in the same system, dislocates from one point and comes to the another point, the crystal density do not changes, but other electrical property changes. Due to the formation of holes, they start to conduct electricity. This is one of the significant change of crystal property due to the crystal defects. Normally, the crystals are supposed to be insulator or bad conductor of electricity at 0 Kelvin. But due to the formation of this hole, the ions and electrons moves in the opposite direction, and thus the electrical work done by the outside charges, electrical work done by the charges flowing from outside is equal to that work done by the hole. Thus, these two work done are equal and opposite, hence net energy change is 0. So, crystal passing of electrical charge through the crystal is a physical change. It is not a chemical change. Now, we are just starting that what are the two types of crystal defects. Are first, point defect, and second, this is line defect. Now, point defects are of three types. First, a stoichiometric defect. B. Impurities defect. and C, non-stoichiometric defect. See, we are starting with a stoichiometric defect. This is vacancy defects, first point. As we have discussed that the higher temperature other than 0 Kelvin, the cations and anions dislocated in the crystal, and this dislocation or migration causes vacancy defects. Sometimes it is also called Schottky defects. Or the extra atom or ions between the two normal lattice points. Creating an interstitial effect. This is called vacancy defect. Vacancy defects are of two types. First, Frankel defect. This consists of vacancy the vacancy in which missing atoms are or ions have moved to the interstitial position position. The second is Schottky defect. This consists of vacancy due to migration of cations and anions keeping electrically neutrality. The crystal as electrical neutral. This is called Schottky defect. Okay. Now, the other type of crystal defects are impurities defects. During the course of the lab uses of different crystals, some impurities can be added, or during the course of the formation of that crystal, some impurities may be added into it. It may cause electrically neutrality or not. So, it will be conductor. So, this is called impurity defect. These are caused by the presence of impurity ion. Foreign ions. In the crystal. Non-stoichiometric defect are the metal excess defect Effect. Solid shows different types of magnetic properties. Such solid magnetic properties which are as below. First, paramagnetism. Second, diamagnetism. Third, ferromagnetism. Fourth, antiferro magnetism. Fifth, ferrimagnetism. These are the different magnetic properties which is produced due to non-stoichiometric defect. These properties are used are used in audio, video and other recording device. And other recording device. Okay. So now all these properties are correlated with the electronic configuration. See, electrons moves in an atoms or in ions along the central positive charge, and due to that movement an electromagnetic wave is generated by the electrons, having two types of field, electrical field and magnetic field, which is mutually perpendicular to each other. The magnetic field is responsible only by the electrons, hence all these properties means paramagnetism, diamagnetism, ferromagnetism, ferrimagnetism, antiferro, all these 5 types of properties are related with the electronic configuration. This is all about today, and from the next day we will start the regular solids and classification of solids. Okay, see you again in the next lecture.